15 billion miles from Earth, traveling through interstellar space at 38,000 miles per hour. Launched in 1977, nearly 50 years ago, and still sending data home. Voyager 1 is the most distant human-made object in the history of civilization. And right now, NASA is doing everything it can to keep her alive. NASA shuts down Voyager 1, instrument to keep probe exploring interstellar space. Hey space family, welcome back to D3, Discover Deep Dreams, your educational gateway to the cosmos and beyond. I'm your co-captain, and today we're talking about one of the most extraordinary machines humanity has ever built. Voyager 1, the little spacecraft that could. The probe that has been flying through space for nearly 50 years, crossed into interstellar space, and is still talking to us from 15 billion miles away. And this week, NASA made a difficult but necessary decision to keep her going, shutting down one of her last remaining science instruments to conserve the precious little power she has left. This is the story of Voyager 1, why she matters, and why the people at NASA's Jet Propulsion Laboratory are fighting so hard to keep her alive. Let's start at the beginning, because to understand why this matters, you have to understand what Voyager 1 is. On September 5, 1977, NASA launched Voyager 1 from Cape Canaveral. The mission was breathtakingly ambitious. Fly past Jupiter and Saturn, study these giant planets up close, and then continue outward into the unknown. Nobody knew exactly how long Voyager 1 would survive. Nobody knew if she'd last 5 years, 10 years, 20. She's been flying for nearly 50. In 1979, Voyager 1 flew past Jupiter and sent back the most detailed images of the giant planet humanity had ever seen. She discovered active volcanoes on Jupiter's moon Io, the first time active volcanoes had been observed anywhere beyond Earth. She revealed the complexity of Jupiter's ring system. In 1980, she flew past Saturn and gave us our most detailed view yet of the ringed planet and its magnificent moon system. And then she kept going, outward, always outward, into the vast darkness beyond our solar system. In 1990, at the request of astronomer Carl Sagan, Voyager 1 turned her camera around and photographed the solar system one last time from a distance of 3.7 billion miles. In that photograph, Earth appeared as a tiny pale blue dot, less than a pixel wide, suspended in a beam of sunlight. Carl Sagan's meditation on that image became one of the most famous passages in science writing. "Look again at that dot," he wrote. "That's here, that's home, that's us." In 2012, Voyager 1 crossed the heliopause, the boundary where the sun's influence ends and true interstellar space begins. She became the first human-made object to leave our solar system, the first piece of human civilization to touch the stars, and she's been in interstellar space ever since. Here's the challenge facing NASA right now, and it's a fundamental, unavoidable challenge. Voyager 1 doesn't run on solar panels. She's too far from the sun for that. Sunlight at 15 billion miles is about 0.00001% as strong as sunlight at Earth. Solar panels would be essentially useless. Instead, Voyager 1 is powered by radioisotope thermoelectric generators, RTGs. These devices use the heat generated by the natural radioactive decay of plutonium-238 to generate electricity. RTGs are extraordinarily reliable. They have no moving parts. They don't require sunlight. They just quietly generate power as the plutonium decays. The problem is that plutonium-238 decays at a predictable rate. Every year, Voyager 1's RTGs produce a little less power than the year before, losing approximately 4 watts per year. When Voyager 1 launched in 1977, her RTGs produced about 470 watts of power. Today, nearly 50 years later, they produce roughly 230 watts, less than half of what they started with. That's not much power. A standard household light bulb uses 60 watts. Voyager 1 is running her entire spacecraft, computers, heaters, communication systems, and science instruments on the equivalent of about 4 light bulbs. And that power is still declining. Every year, a little less. Every year, engineers have to make harder and harder choices about what to keep running and what to turn off. In late February 2026, something alarming happened. During a routine maneuver, Voyager 1's power levels dropped unexpectedly, bringing the probe dangerously close to triggering an automatic fault protection shutdown. A self-preservation response that would have forced engineers into emergency mode and potentially cost them critical control of the spacecraft. The power drop was a warning sign, a clear message from a spacecraft 15 billion miles away. I'm running low. Something has to give. Engineers at NASA's Jet Propulsion Laboratory began evaluating their options. The goal was clear: keep Voyager 1 operational, keep her communicating, and keep her science going for as long as possible. But something had to be turned off to make that happen. On April 17, 2026, NASA made the call. Engineers sent a command to Voyager 1, traveling at the speed of light, taking over 20 hours to reach her at 15 billion miles, telling her to shut down the low-energy charged particles experiment. The LECP. The LECP had been operating almost continuously since Voyager 1 launched in 1977. For nearly 49 years, it had been measuring charged particles in the interstellar medium, recording cosmic rays, solar energetic particles, and the charged particles streaming through the space between the stars. It had given us an unprecedented picture of what interstellar space actually looks like from the inside. Data that no other instrument in human history has ever been able to collect, and now it's off permanently. It will never turn on again. There's something genuinely poignant about that, an instrument that launched before many of the scientists studying its data were born. An instrument that crossed into interstellar space and kept working, kept measuring, kept sending data home across the void. Gone now, a quiet farewell to a faithful scientific companion. After the LECP shutdown, Voyager 1 has 2 remaining science instruments still operating: the plasma wave subsystem, which listens to the waves and oscillations in the plasma of interstellar space. Think of it as Voyager's ears, listening to the sounds of the space between the stars, and the magnetometer, which measures the magnetic fields in interstellar space. 2 instruments, 2 windows into a realm no spacecraft has ever explored before. And both of them are still working, still sending data, still doing science that simply cannot be done any other way. Because here's the thing, Voyager 1 isn't just a historical artifact, she's still doing active, irreplaceable science. The data she sends back from interstellar space cannot be replicated by any other instrument currently in existence. We don't have another spacecraft in interstellar space. We won't have one for decades. Whatever Voyager 1 learns, whatever she measures, whatever she hears, is data we can get from nowhere else. Here's where it gets even more interesting. Shutting down the LECP is buying time. But NASA engineers aren't just playing defense, they're planning something ambitious, a maneuver being referred to as the Big Bang Fix. The details are complex, but the concept involves a risky reconfiguration of Voyager 1's power management systems, essentially a major surgery on a spacecraft 15 billion miles away that takes over 20 hours for commands to reach and another 20 hours for responses to return. If it works, the Big Bang maneuver could extend Voyager 1's operational life, potentially keeping her going for several more years beyond what her current power budget would allow. If it doesn't work, if something goes wrong during the maneuver, it could end the mission permanently. This is the kind of engineering challenge that keeps the team at JPL up at night, the kind of problem where the margin for error is essentially zero, where a typo in a command sequence could silence the most distant human-made object in history forever. And yet they're going to try. Because that's what you do when you have a spacecraft like Voyager 1. You fight for her. Every last mile, every last watt, every last data packet. Let's step back and ask the question that underlies all of this. Why does it matter? Voyager 1 is a 50-year-old spacecraft running on the equivalent of 4 light bulbs with 2 working instruments, sending data at a rate slower than a 1980s dial-up modem. Why does NASA fight so hard to keep her going? Because of what she represents. Voyager 1 is proof of what human beings can do when we dare to reach. She was launched with 1970s technology less powerful than a modern smartphone. And she has outlasted every expectation, every prediction, every estimate of her operational life. She has shown us Jupiter, she has shown us Saturn, she has given us the pale blue dot, she has crossed into interstellar space, she has measured the medium between the stars, and she's still going. Every day that Voyager 1 operates is a day of data from a place no other instrument can reach. Every signal she sends back is a postcard from the frontier of human exploration, from the space between the stars, where no human-made object has ever gone before. When Voyager 1 finally goes silent, when her power drops too low and her transmitters shut down for the last time, it will be the end of an era. The end of a 50-year mission that redefined what humanity is capable of. But until that day comes, NASA's engineers will keep sending commands into the darkness, waiting 20 hours for them to arrive, waiting another 20 hours for Voyager's response, fighting for every last watt, every last instrument, every last bit of science, because Voyager 1 deserves nothing less. On April 17, 2026, NASA shut down the low-energy charged particles experiment aboard Voyager 1, an instrument that had been faithfully working for nearly 50 years. An instrument that had crossed into interstellar space and kept measuring, kept sending data, kept doing science until its very last moment. Voyager 1 is 15 billion miles away. She has 2 instruments left. She's running on less power than a handful of light bulbs. And she is still the most extraordinary spacecraft humanity has ever built. Keep flying, Voyager. We're listening. If you like space exploration, don't forget to like, subscribe, and ring that notification bell so you never miss a single D3 episode. Keep looking up.